Hello, exceptions and testing. So this topic, in simple words, if your code faces some issues, some challenges, just a moment. So if the code faces some issues or some challenges, errors, input error from the user, error during the execution of the code, the computers will never do errors. We do the errors, then the computers will follow us, then the computers will do the error. So if I'm dividing by 0, for example, in my code, this will create a divide by 0 error. So how to deal with these types of errors? If someone in eBay search box, for example, put some code there like SQL injection, would that run? Of course, we need to think about that, stop that from happening, controlling the inputs from the users and deal with different situations. So this is one thing. The other thing is testing our application. We said that we will decompose the big application into smaller parts. Then we needed to make sure every part is working fine. Then we will link them, we will call them. Also, after that, we need to test the whole application. Otherwise, we can see disasters. So exceptions here. So method takes 0 or more arguments and returns a value or a list of values. So what if there is no suitable value to return? You remember in the previous session, I mentioned algorithm about comparing two values. What if we put same value in each variable? So we should get an error message or something saying you're getting equal values in both variables. Good. So what if there is no suitable value to return? What will happen? So we need to think about that. For example, result here, first letter of hello. When we print result, it will print H, but result first letter of empty. So print result, what is printed? So it's empty one. So we need a way to return something that indicates an error, as I mentioned. So we call that exceptions. So the method, as we agreed in the previous session, it will return a value or raise a named exception along with a string explaining why the exception occurred. So we need to think about that. When we call the method, we can get the return value and some options to catch the exception. So we have a code here raising an exception, and we have some examples of raising an exception. So let's see what is there. It's telling you first letter of, it's a function, return the first character of the string argument, raises a value error exception if the argument is argument length is 0. Okay, so here we are defining first letter of string, error if the string is empty. So if length of the string equals 0, raise value error, need one or more characters. So otherwise, return the first character, return string 0. What is there? Okay, so can you try that? Of course, we need to call this one and print, but good to write this one in your Sony interpreter. So the exception called value error, and this is the exception we created. Why? Because we need one or more characters if we input 0. So we always need a way to call a method with arguments, get the return value if there is one, or catch the exception which is raised and sent to us and deal with the exception. So we need to think about that. Okay, so catching an exception, we try, so we run this code, execute this code when there is an exception, else no exceptions, run this code. So this is the way we design, the way we think about expecting errors here. So we have some important notes here. A try except block can have multiple except statements. So this is useful when the try block contains statements that may throw different types of exceptions. We will see some examples in a moment, but I'm just reinforcing the information we explained from the slides. So CALSO provides a generic except clause which handles any exception. The else section is optional. The code in the else block executes if the code in the try. So block does not raise an exception. So the else section is a good place for code that does not need the try blocks protection. Examples. So with the examples, these blah 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 things will will be more clear. Sometimes we IT people, we don't like these blah 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 things. I'm not sure if any of you likes that, but personally I don't like too much text on the slide. I prefer these types of slides with some instructions or something to configure or some photos, yeah, or diagrams, yeah. Anyway, example here without catching an exception. So we are not catching any exception here. So the main program, try it out. So you can try that also. So print first letter of football, print first letter of empty. So here we get some, for the first one, we got the F for the football, but the second one gives error. So raised value error. Okay. With catching an exception, so this is the exception from the interpreter, but this one from our design. So now do it with exception catching. Try print letter of football, print first letter of, accept the value error as error, print got exception, comma error. So when you run, you will get F, and got exception need one or more characters. Can you try that, please? Can you try that? Yes, now. Yes, now. All good? Okay. Okay, now some notes or points when we think about designing methods. So what arguments do I need to do in my job? What argument values don't make sense? So raise an exception, or can I message them to make sense? And document both of the above in the API comments. Maybe at some point I realize I can't return a sensible value, raise an exception, otherwise return a result as per normal. So here I'm thinking as a method myself. Some discussions, some list of useful exceptions. So you can refer to this one for some additional readings and useful exceptions. Good idea to go through this one. So we have zero division error, as I mentioned, assertion error, nothing left from the file or keyboard when reading, input output error, try to open a file that doesn't exist, value error, argument values are not acceptable, sys exit, stop the script immediately, and some other exceptions, sys exit 0, stop, indicating that the script was supposed to stop. Example, user did file exit. So sys exit 1, stop, indicating something abnormal happened. I had to stop. I could not proceed any further without causing more errors. So we have some assertion exceptions. An API is a contract between the method and the caller of the method. You remember the API discussion yesterday. So different applications deal with each other, or even different components of the same application deal with each other. So here, caller promises to give these arguments within these sensible limits. Method promises to process them and return a result. So this is what's included in the contract. So as a method, we cannot trust the caller. We write buggy code sometimes. Someone else writes buggy code, buggy full of bugs. The input data came from the user, or a corrupted file, or a corrupted database, or even malicious hacker, or whatsoever. At any point in our code, we can assert something which we assume must be true. So again, what we are discussing here, the way of thinking, we need to think when we design big application, big program, and we call different methods, we call different functions, different modules. We might face errors, especially with input from users or input from other applications and using our APIs. So if it fails, an assertion error exception will be raised. Defensive programming as a method, assume our caller is stupid or malicious. So when we program, we have what's called the defensive programming. And maybe this is the most important idea we should have from programmers' point of view, but we are not here as programmers, we are here as security professionals. So we need to think in a defensive way, so including the programming and developers team. So defensive programming as a method, assume our caller is stupid or malicious. We need to assume that. Test our assumptions before we do our work. If this raises an exception, not our problem. If the caller's problem, it is the caller's problem to deal with. So we stop running, but sometimes the applications will fail and open all the ports and lose controls, so hackers can take control or get the data. So here we have assertion example, rewrite of old method. So here, this is the first letter of function or method. So return the first character of the string argument. It will raise an assertion error exception if the argument length is 0. So define first letter of string, then ensure we have something in the argument. So assert length of the string greater than 0. Need one or more characters. Otherwise, return the first character. So here, the main program tried out first letter of football, then print first letter of blank. So F, then trace back, most recent call last, some print first letter, assert length of the string greater than 0. So we have some errors here. So at any point in our code, we can assert something which we assume must be true. So in the middle of an algorithm, after we ourselves call a method and get back a value, perhaps we can't use the value that was returned. So usually best never to catch an assertion error. Normally indicates a bug somewhere or your assumptions are invalid. So we need to think about that and test our code. So how can you know the code is working? Of course, you test the code, but if we have different methods, we will try each of them without linking, then after linking. And usually we separate the designers from, the developers from the testers. So testers, they are different teams in the development environment. In real life environment, we have testing team. So if this is my code, of course, I will think it's the best code ever made, but testing them or testing the code by someone else will ensure that we are doing the right thing and there are no vulnerability as much as we can, and errors and so forth. So if you spot a bug and fix it, how do you know that you actually fixed it? So how do you ensure that future changes to your code don't reintroduce bugs? So, or add new ones? You need to test your code to ensure that it is working. Now, I'm expecting a question here saying, after what we are discussing here, we still see operating systems and applications full of bugs and full of errors. That's why big organizations like Microsoft or Apple or other organizations, they release security patches, updates for their software, for their applications, for their operating system. Yes, because first thing, there is nothing called 100% perfect thing. This is one. Number two, the budget for testing, it's huge and it's always a time constraint, it's a money constraint, and in many cases, they take shortcuts. So this will, of course, raise some errors in future, or if the application is downloaded like a million times, so the server can't handle that, for example, and the overload of data on the application can also crash the application, and so on. So we need to plan for the testing. We need to have different teams for testing. We need budget, we need time, we need criteria how we will test this application. It's a totally different training in testing. It's different than programming, different than cybersecurity. And managing this environment, we have what's called the DevOps, development and operation standards. So totally different qualification and studies. So we need a working code. So we will test the code. So the code is performing what we needed from. As we mentioned, the API is a contract between your module and the outside world. So you need to make sure this is what the module does. You accept these inputs. So other inputs are unacceptable. On success, you will return the results expected. On failure, you will display some errors, or you will do or execute some commands, like, for example, exit or print or save or whatsoever. So for the tests also, we write the tests so we can check if the code is working or not. So we have unit testing, and this is a procedure used to validate that individual units of source code are working properly. Then the unit is the smallest testable part of an application. We have definition from Wikipedia saying in procedural programming, a unit may be an individual program, function, procedure, etc. While in object-oriented programming, the smallest unit is a method. So unit is a method, but method is in object-oriented programming, and the unit is in procedural programming. Different types of programming, and here some explanation of the unit testing. So we have a set of inputs, so we can test the function and the expected output. If we have the expected output, so this is fine, of course, it passes the test, it's good. If it returns some other values, so it fails the test, we can have wrong values in the logic, or in the design, or in syntax, it depends. So if we have some other values, it fails the test. So here, first letter of unit test number 1, argument is purple mushroom, so we should get P. First letter of unit test 2, argument is blank, so we should get assertion error. So we write the test and we prepare the test, so we plan for that. We can have different ways of designing the test and developing the test. It could be even written on a piece of paper, or different codes. And when we have a bug, we make sure it's fixed. So we try with different tests and different types of tests. So here there is some documentation on pythontest.org. So this can give you a framework, which is a standard in case you're planning to work as a programmer, developer in Python. So this site will be one of your main references. But for assessment and unit-related assessments, you don't need to go into these details, but this will give you an idea about how the real-life environment in programming works. Okay, so good unit test, we easy to write, intent of the test is clear, it's readable, it's reliable, fast and easy to run, truly unit tests. So you are the developer, I'm the tester. We need to agree on some kind of criteria, how I will test your application, how I will test if it works fine or not, maybe the speed of the application. So it works fine, but the speed is not fine. Excuse me. So here we have some activities you can do after the delivery and stopping the recording. But here you can design some unit tests, either individually or a group of 2 or 3. So receives a single string argument, returns a string with the first 3 lowercase letters in the input argument. You can discuss and write a more strict API document for this, include what inputs would be considered bad. You can discuss that definitely on Discord, and you can work on creating these design or test for the units. So write on paper a set of 6 unit tests for the method. What is the input? What is the expected result or exception? So you can start writing a completely bogus method. So returns a string with the first 3 lowercase. So defining here first 3 lower string. So definitely wrong. Return ABC. Now write the main program. So unit test on the method. If first 3 lower piano equals P equals PIA, print test1 okay, else print test1 fail. So you can type it this one. You can write lots of tests if you want. This way, if print else, so we are using if else, if else, if else. So here, cat, dog, fish, including ATO, else, print, fail, some, first 3 lower. So is that equals FUG, test 3 okay, otherwise fail. First 3 lower, only 2 lowercase, so WO okay or fail. So you can write the code. So this is good. See how hard it is to understand without the comments. I want you to try this code. So once we're done with the delivery, please try every code on each slide, please. This is very important. Try every and each code in each slide. Go through these slides again and again, then do the exercise, please. This is very important for gaining this skill. Programming skill, it's like driving. You need to exercise, not only read about it. You need to practice exercise. It's like driving or swimming. You must do it. So we did some exercises today, which is good, but also please continue the exercises after I stop the recording. So here we pass the test and then test method that raises exception. So we are defining the first letter, then need 1 or more character. If no, we will have some errors here, like failing. Okay, so yeah, I know today's session was a bit lengthy, but you will have the rest of the week to work on your exercises and also review these ones. Please feel free to email me or we discuss on Discord. I'm always checking my Discord with everyone, and I see people, they are helping each other, which is great. We have also the study group in both in Townsville and Cairns, which is great. Thank you for creating these study groups and helping each other. Thank you, everyone. I'll stop the recording now and I'll stay online for answering further questions. Thank you.